Hi. Okay. I actually did do one time with my son and daughter the K1 auto racing over in Ontario. I personally didn't like the experience because as I was going around those curves, it was the defensive driving that kept stopping me. And it was just like a natural thing that I had. Okay, we do need to get going. We got to talk about smog. And we're now chapter 18, air pollution. Uh, it's 18.2b, that's what I would call it. And we got to talk about smog. Our last video, we did talk about what was air pollution. We talked about primary pollutants and secondary pollutants. You guys really need to know that above all else, okay, for the chapter. Now, that being said, we got to talk about smog. Not this smog here. Now, there's two basic kinds. There is photochemical and industrial smog. The photochemical smog is the brown air smog. This is what we pretty much have here in Southern California. As you can see in this picture here, I believe it was probably taken from Hollywood, but this is the brown air smog. And what you're seeing with your eyes isn't that bad. It's what we don't see with our eyes that's bad. Okay? So the thing about photochemical, break down the word photo, like photosynthesis, photography, for example. So what in the world does that look like? Okay? Well, photo means light, and this is the kind of smog that gets activated by light. Now, it is a mix of NOx, the NOx, and the volatile organic chemicals. Okay. I do want to point out when we say NOx, think NO, NO2, NO3. That's what we mean by NOx. So I'm going to use the term NOx to refer to NO, NO2, NO3. Okay. Now, the volatile organic hydrocarbons with the ultraviolet radiation, that's a mix. So what we have here, a mix of NOx and volatile organic hydrocarbon compounds with UV. Okay, the VOHC. Okay, and that again, that comes from natural and man-made sources. So there is air pollution, again, that's made from natural sources. It's not that the environmentalists can sit there and blame humanity for it. Okay, you got to blame what's going on in nature. All right. So trees, do actually trees contribute to this? Yeah, they do, but they also do a lot of really good things too. For one thing, they give shade, which means less energy being needed in terms of for cooling a house, for example. So trees do provide the shade. You could arguably, plant trees around the house, and that helps keep the house a little bit cooler in the summer. So you got less energy used for the air conditioning. Now, what else do trees do? Well, they do the photosynthesis. They take in carbon dioxide, give off oxygen, but they also take in and absorb various pollutants that are there. So trees are very, very useful. Okay, now they do give off the VOHC, the volatile organic hydrocarbons, which are ingredients in photochemical smog. Now, the VOHC will also increase when the tree dies and it's breaking down. Again, this is a natural process. This is not a man-made process there, okay? I get a kick out of the time when there was the global warming was the big thing, and you had these people go and buy large areas of the 100-year-old trees, the old growth forest, because we wanted to keep our carbon sequestered and we're so good at doing it. Well, hey, what happens when those trees die? Because all living things die, right? Those trees are going to fall, they're going to decay, and guess what? VOHCs are going up into the air. Celebrities and political causes. Please become educated. That's what you need to do. Become educated. All right, let's keep going. So that's photochemical smog, and that's pretty much what we see in Southern California. Now, we do have industrial smog and gray air smog. Industrial smog, you're going to see that in places like Germany, where you have a lot of factories, particularly areas where you have a lot of factories there. So in industrial smog, you have a mix of sulfur dioxide. Now, wait, what could be a source of sulfur dioxide? Coal? Yes, coal. Okay. You also get sulfuric acid drops, acid rain, and particles of coal and oil. This is all factories do this. They use it, they burn it. That's how they power the machines. Okay, so you get pollution that comes out of it. So, gray air smog, on the other hand, is gray color smog formed by salts and carbon, which is the soot that I had mentioned earlier in the last video. Okay. Now, wait, salts? Well, some of the salts may be coming from the ocean. Yeah. And you know where's the source of salts in Southern California? It's a secret. How about the Pacific Ocean? Yeah. So the Pacific Ocean is also a source of salts for us here. Okay. So you got your basics. Photochemical smog. You got your industrial smog and your gray air smog. Those are your three basics. Now, there are things that will help form it, factors that will either improve on it or not. Factors that are going to increase the making of the smog, or it's going to actually cut down on the smog. Got to get my water break here. They don't sell these bad boys anymore. Okay, let's keep going. So rain and snow, it actually helps cleanse the pollutants out there in the air. And so, typically if you ever notice when we've had a bunch of rain and when the rain stops the next day, it's a beautiful sunny day and you kind of notice that the sky is more clear, you're getting more blue. That's because rain helps clean pollutants. How about salt spray from the oceans? They wash out particulates and water-soluble pollutants. Wow. Now, like I said, this is a big deal. This is like section 7, the last section of the AP for the AP exam. So this is a really important chapter. You guys need to know this stuff, okay? Wind. Ugh, yes, wind. It sweeps the pollutants away and dilute by mixing it with clean air and fresh air, and it helps, but that means it's going to go somewhere else, dude. It was in 1971 or 76 that Antarctica, they finally discovered air pollution. There is no place on the planet you can go that you will not have air pollution on the surface. You won't. That's just the way it is, guys. Okay. Factors that will actually increase pollution. Urban buildings. Now look at the arrow going up. When the arrow is going up, that means it's increasing. So we say factors that increase pollution. If the arrow is going down, that means it's decreasing, it's less. So urban buildings slows the wind speed down, okay? It cuts down on dilution and removal of pollutants. That might be why we tend to see smog more in cities as opposed to the countryside. Hills and mountains. Well, that decreases the airflow in the valleys, and it does allow the pollutant levels to rise, to increase as a result of that. Because if the air is not flowing through the valley, then the pollutants tend to stay there. And as we make more pollutants, the level of pollutants rises. Okay? That's a pretty important thing. And like I said, guys, if you have to pause, rewind, feel free to go do it. By all means. This is your time. Okay? The next one is high temperatures. They promote chemical reactions leading to photochemical pollution. Ooh, yeah. High temperatures promote chemical reactions. Now, hey, that would be kind of a useful thing in AP Chem, where we talk about some of those chemical reactions. When you add energy to a reaction, you make it happen, right? Well, this is where it's the real world. This is chemistry in the real world. High temperatures promote chemical reactions leading to photochemical pollution. Oh. Okay, let's move on. Okay, the grasshopper effect. Okay, what the grasshopper, it's not talking about the little animal that goes and eats grass and eats crops. Okay, we are talking about that it bounces from place to place to place. And what this is, this grasshopper effect, it's a transfer of volatile, remember volatile being easily evaporated, air pollutants from the tropics and the temperate areas to the poles. That's the grasshopper effect. So we can transfer the volatile air pollutants from the tropics and the temperate areas. We're kind of in the temperate area here in Southern California. We are not in the tropics. To the poles, to the North Pole, to the South Pole. So even Santa's workshop gets it. All right. For us, we have to talk about something called a temperature inversion layer. We're still dealing with factors that increase pollution, right? So, temperature inversion. What does inversion mean? Here is a calculator. This is an inverted calculator. It is upside down. Okay? I am not going to turn my head upside down. But this is what we mean by inverted. Regular, inverted. Same thing with this hobby blade. Okay? That's my personal one. This is right side up. This is inverted. We can talk about Alien's tacky glue. Right side up, inverted. So, temperature inversion. What happens? The warm air layer is on top of the cooler air layer. Now, here's the question. You know that warm air rises, right? Cool air settles down. So when you look at this diagram here, this is what's happening. You got a city, you got some mountains, you got warm air, you go up into the cool air, and then you go to the cooler air. That's the normal order of things. Life is grand, beautiful. Thumbs up. Certainly gets my approval. Okay, that's our normal thing. All right. But what if you got the warm air layer that's on the top of the cool air layer? Well, the cooler air layer cannot rise. It cannot go through the warm air layer, and it traps the pollutants that are there. Okay, the pollutants concentrate at the ground level. They never rise, and what's happening is the pollutants get stuck there. Okay, like my hip hop career, or should I say rapping career. Oops. Come on. Now, temperature inversions happen in very few places on the earth. There's a couple of reasons why. One of those, you have to look at the geography, the physical geography of the land, something known as the topography. Where are the hills? Where are the mountains? Where are the valleys? Where's the ocean in all relation to this? So there's two things that happen. There's two types of topography that will contribute. One, you have a city that's in a valley that is surrounded by mountains. That's case one. It experiences cold and cloudy weather during part of the year. That's where you get your temperature inversion. Okay? This thing would actually work. Apparently not. Now, that's one situation. Here's a second. A city with an ocean on one side, mountains on the other three sides. You got a sunny climate, millions of people, lots of cars, light winds, and ding, 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 ding. Not Jerry Ding, if you remember that fine fellow. But this is what happens to us in Los Angeles. In LA, we experience the temperature inversion layer. That does increase the smog because we have that warm air on the bottom in the valley. We have that cooler air on the top. Okay. Sorry, let me rephrase. Yeah. Cool air on the bottom. We have warm air on the top, and it can't work its way through. Okay. So that's what we have in LA. At least half of the year in the summer and the fall. That's where we get to experience the temperature inversion layer. Woo! I love LA. So this would explain why we have a lot of this. This is a result of the temperature inversion layer. This is from the Griffith Observatory. It's not my photo, okay? But yeah, that's downtown LA. You get to see the brown smog there. Now, what kind of a smog is that? It's photochemical, okay? We don't have a lot of industry in the LA region, not like compared to, over in Pennsylvania. Randy Newman wrote the song I Love LA in time for the 1984 Olympics. That was a boomer time. Great. Done that. How in the world do we reduce air pollution? Some things. Heavier particles than air settle onto the earth, and that does cut down to it. We got rain and snow that helps clean the air of the pollutants. The salty sea spray, and not Long's salt, okay? Salty sea spray from the ocean helps clean the air. Wind and chemical reactions, because some of the pollutants are actually removed by them. So there are some things going on. What increases air pollution? Urban buildings, again, slow the wind speed, reduce dilution and removal of pollutants. Hills and mountains, they reduce airflow in the valleys. High temperatures promote chemical reactions leading to photochemical smog. And emissions of volatile organic compounds play a large role in photochemical smog development. We talked about the grasshopper effect, okay? And I mentioned it briefly earlier. Again, volatile air pollutants, they're transferred by evaporation and the winds. And it goes from the tropic and temperate areas to the polar regions. Now, some people would say, dude, you're totally making this up. It's fake news, brah. No, brah. We got the evidence. Polar bears, seals, and natives. That's the native folk who live there. They have high levels of toxins in their body. Toxins that normally are not found in those areas. Where did they come from? It had to come from other places. And hence, that's why we have the grasshopper effect. Because we got those pollutants that come in from the tropic and temperate areas and they bounce their way to the polar regions. North Pole, where Santa's workshop is, and the South Pole, where the penguins of Madagascar are trying for. Now, another piece of evidence. Pilots, up in the air, they've reported seeing red-brown haze over the polar regions. So we know there is no place you can escape air pollution on the Earth, okay? You can't. Now, we also have the temperature inversions also that increase the air pollution, causing the pollutants to go to build to high levels. And with that, guys, we're done. So we talked about factors that increase air pollution. We have looked at the factors that help reduce air pollution. Sadly, we've got a lot more that increase it. We talked about the idea of temperature inversion layers. Okay. What's causing it? Two situations that cause it. Southern California, we do experience temperature inversion layer in the fall and the summer. Interestingly enough, the hottest times of the year, huh? Ooh. Okay. We talked about smog. Okay. We looked at factors that affect it. We looked at industrial smog, what it's made of, gray air smog. We looked at photochemical smog. We said trees contribute to this. Yes, they do. We looked at the idea of photochemical and industrial smog as well. Okay. And with that, ladies and gentlemen, I am stopping here. Hey, I'm hoping this is eye opening. Okay. It's a challenge that definitely for the 21st century, this has been a challenge that's been there for a long time. And this is one of the reasons why you have the global climate change people sitting there and trying to do something about this. I think they're going about it wrong, but it's important that you guys understand air pollution, what it is and what it isn't, and what causes it. Okay, that's it. You guys take it easy. God bless you and take care. And remember, Jesus is a whole lot bigger than all of this. Bye.